Hi friends, welcome back. Today we are going to solve a Leetcode problem 472 concatenated words. This is one of the hard problems on the Leetcode, a very important problem from coding interview perspective, and this problem is asked by many big companies in their interviews. So make sure you understand this problem. Please watch this video from beginning to end so you will understand the concept how we can solve this problem. If you are new to my channel, I just want to mention that my channel is dedicated to help people in their Java J2E and coding interviews. On my channel, you will find lots of helpful videos that can help you in your Java and coding interview preparation. On my channel, there are over 400 different varieties of coding problems which are taken from previously asked coding interview questions by Google, Facebook, Amazon, Apple, Microsoft, Yahoo, and many other big financial companies, and those constitute a very wide range of important coding questions varieties such as BFS, DFS, matrix problems, graph problems, coding questions related to binary search trees, as well as linked list strings, optimization problems, and lots of logical questions that can be solved with the help of different data structures such as maps, sets, queues, stacks. So if you are preparing for Java interviews or coding interviews, this channel can definitely help you in your preparation. So please subscribe to this channel now. So let's start with this problem 472 concatenated words on Leetcode. This is a hard and problem, very important problem. As you can see, it's very likable problem from the like and dislike ratio. So let's first go through the problem statement, then we will go through the some examples and we will understand how we can solve this problem, right? So let's start. So given an array of string words without duplicates, return all the concatenated words in the given list of words. A concatenated word is defined as a string that is comprised entirely of at least two shorter words in the given array, right? So at least two words should be there, right? Then only we can say that it's a concatenated word, right? Otherwise, if it is just a single word, it cannot be a concatenated word, right? Let's just take a look at the constraint first and then we will take a look at the example. So words array length can be between 1 and 10 raised to 4 inclusive. The word length by itself can be between 0 to 30 inclusive, and it only consists of lowercase English letters, which means that it will consist of only A to Z, right? Lowercase English letters, and the sum of words of length can be between 0 to 10 raised to 5, right? So these are the constraints. So we will take a look at the first example they gave us, like here. So they are giving us the words and we have to find out which are the concatenated words in this list of words, right? So first I wanted to mention you like that we are going to solve this problem using a very popular data structure called as try, right? To solve these kind of problems, try data structure can be very helpful, right? It's something similar to tree, but it's a little different, so it is called as try, right? So it will have a root, and every node in the try data structure will have 26 children, right? 26 children. So for example, this is the root, so it can have maximum 26 children, right? Always. So for example, A, then you can just say B, like this, right? All the English alphabet letters can be its children, right? C. So if you go, the last one can be Z, right? So total 26 children every node will have. Now for example, if we want to insert one word called as cat here, right? So then we will go to here, which is C, right? So we will put C here. Now for the place A and B and other characters, these will be null basically, right? This is just to show you that we actually can have 26 children for every node, right? But for example, let's say there are no words and we are just starting from the scratch, right? If we are starting from the scratch, so you just ignore this. So let's say, for example, this is our node, so we will just insert C here when we are inserting word cat in the try data structure. Right now A and B will be null basically, right? So I'm not showing you other characters like D, E, F, G until Z, they are null basically in the beginning, right? So when we see first character C, we will create a node and we'll just insert that node at the place of C, right? So this is the root, So this is the root, right? So we'll insert C, then we will insert A. So C then A, right? Because here A is there after C. Now C will have other children also, like A, like B, C, D, E, F until Z, right? But those are null, so I am not showing you that basically, right? But they are there. You can assume that they are there, but they are null, correct? Now T means the A will have a children T or child T basically, for example, right? So A will have again A will have another 25 children, but those are null at this time, right? Whenever we find a character, only we will create a actual node basically, right? For example, T. So this is how the trie data structure works, and we will have word CAT here, correct? So let's take this first example that they have given us, and you will understand more, right? So I created this trie data structure, how it will look like for the words they have given us for us, so you will understand it easily, right? So let me just pick the color. So for example, word cat is there, right? So this is our root, so we will have CAT, right? Cat word is there, right? And we will have a dollar. So for example, dollar is to mark that end of the word basically, right? So it means that CAT word is there, right? After that, if you look at the other word, then CATS is there, right? So CAT and S, right here. So this is also we will mark as the end of the word, right? So this is the end of the word, right? After that, the other word, so we are basically, first thing we are going to do to solve this problem is we will create a trie data structure and we will insert all these words, right? So how the trie data structure will look like after insertion, that's what I am showing you here, right? So now cats, dog and cats, right? So we will start from root, we'll go to CATS, cats, right? Cats is there. So after that we will create DOGS, correct? So I'll just move it because it's a big word, right? So I cannot show you the completely. So now as you can see, sorry, dog, and then cats again, CATS, correct? And then we'll put a dollar, means end of the word, right? So this is the way the trie data structure will work, right? Now other words are also there. So for example, dog, right? Dog is here, so I just put a dollar, so it's end of the word. Then dog, cats, dog is also there, right? So we will put dog, then cats, and then dog, right? And then we will put the end of the word here. The termination is, I just put it in the red color, so you will notice that the word is ending there basically, correct? Because in trie data structure it is important for us to understand when the word ends, right? Otherwise we cannot process that word. So hippopotamuses is also there, so I just create this word. As you can see, hippopotamuses is a big word, and at the end I'll just put a dollar here to understand that it's a end of the word, right? After that, rat is there, correct? So this is another word now, rat. So it's terminated here because rat is one word, and other word they have given us is rat, cat, dog, cat, right? So rat, rat, then cat, dog and cat, right? CAT. So this is again ending of the word here, right? So this is how the trie data structure will look after we insert all these words into the trie, correct? So I just wanted to show you the trie data structure first. So now once we create the trie data structure using these words and we inserted all the words, what now we have to find out which are the concatenated words here, correct? Which are the concatenated words, and as they say in the problem statement, the word can be concatenated if at least it should be comprised of two shorter words, correct? Two shorter words. For example, let's say let me show you. So now for example, if you look at this cats, dog and cats, right? These words is a concatenated word. Why? Because it is comprised of cats is one word, dog is another word, and again cats is another word, right? That is given to us. Those are valid words that are given, right? So cats is there, then dog is also there, correct? And then cats is again here, cats there, right? So cats, dogs and cats, dog and cats is this one, right? Is a basically concatenated word, right? So as you can see, we have to output all the concatenated words. So these are all three concatenated words, right? Other words, for example, cat or cats, it's not a concatenated word, right? Because it is just a single word, right? We need at least two words so that we can combine them together to make a concatenated word, right? So cat or cats, those words are not concatenated, right? Because they are just by themselves, right? Only single word. So now we will see how we can solve this problem with the help of try, right? So what we will do is we will go through each of this word, right? After we inserted the words into try, and we will check if we can find that as a concatenated word, right? So for example, let's say we are going through cat, right? So cat, we will go and we will search in our try data structure. So we find a word cat, but this is a single word, correct? Because we cannot combine it with other word. Basically it is just single word, so we will not this is not a concatenated word, right? Then cats also, if we go through cats again here, right, in the try, then cat and s, right? So this is a word by itself which is present in our try data structure, but we want multiple words, right? Not single word. So this is also not a multiple word, so we cannot count it as a concatenated word. Now let's go to the next one. Now let's say cat, dog and cats, right? So I'll just write down so I can explain you here. So cats, dog and cats, right? So this is another word that's given to us. So what we will do is, now we will keep doing the prefix basically of this string, right? So first we will check C. Is C there here as a word? No, C is not a word, right? cat is a word, but C is not a word, right? Because it's not ending basically. It's not a ending word, right? So it's not there. Then we will keep expanding basically, right? Now I will search for ca. So ca is also not a word, right? Then we will keep expanding as a prefix. Now cat, correct? Now cat. So we will go to cat. So cat is a word because t is a ending of the word, right? So cat is a word. Now what we will do is we will cut it off here, and now we will wanted to check if this is also another word basically. So s is not a word, right? So it cannot be the concatenated word, right? Because s is not a word, correct? So now basically we have to now ignore that cat. So cat cannot be a choice basically, right? Now what we will do is we will keep expanding our prefix. Now cats will come basically in the next time, right, as a prefix. So if you go through this try, the cats word is there, right? Here cats is there. So it means that we will cut it off now, like this one, right? So cats, we already found that word is there. Now we wanted to check if this can be a concatenated word, right? So dog, we will go again, again we will do the same thing, right? We will go first d, then do, and then dog, right, prefix. So once we reach dog can be a word here, right? Because it's ending here, correct? So dog can be a word. So what we will do again, let me change the color. So what we will do, we will again cut it now here basically, right? Because now we found dog can be a word. Now we wanted to make sure that the remaining can also be a word, right? Then only we can say that it can be a concatenated word, right? Now again we will do the same things. First we will check c, then ca, then cat, and eventually, like when we go to cats, right, then cats can be a word, correct? Cats can be a word in the try, right? So this way we can we can assure that this is a concatenated word, because it is comprised of three words. This is one word, this is second word, and this is a third word, right? So when we find a first word, what we will do is we will create one flag that will tell us that, now we are looking for the second word basically, right? We will use one boolean flag that will tell us that we already found one word and now we are trying to look for second word, right? For example, cats we already found here. Now we wanted to check if there are multiple words that are so that we can assure that that is a concatenated word, right? That can form a concatenated word, because concatenated word can be formed by more than one word, right? So flag we will use boolean to understand that, right? So this is our approach to solve the concatenated words hard problem on the Leetcode using try. So I think you got the idea. So we can just go ahead and take a look at the Java code. So you will understand more now. So let me just make it a little big. So first thing is we will create one static class here. This is a try. We are first implementing a try, right? So try is a static class and it will use root as a try node, right? Try node is has two fields. Is word is there. It is false in the beginning, right? And every node will have 26 children, as I explained you, right? Why 26? Because English alphabet has A to Z 26 character, right? As we have seen here, right? 26 character. So that's why we will always every try node will have 26 children, correct? So here we are implementing try first, and we have just constructor root is equal to try node, and we are inserting, like creating the insert method and search method, right? So insert method, what we are doing here is we will go character by character and we will keep creating node, right? If it's not already there, if it's already there, then we will just uh, update our node to that node basically, correct? For example, if node C is not there in the beginning, we will create the C node here, right? And then a node also we will create. A is not there in the beginning, we will create A. T is not there in the beginning, we will create T, correct? Now if let's say there is another word, let's say COOL, we want to insert in the try, right? So we will keep checking if from the root. So root, does it have a child called as C? Yes, it has a child called as C here, correct? So we don't have to create basically, correct? Now we will go forward. Now does it have a child called as O? No, it's not having child called as O, so we will have to create another node for O basically here, correct? And then again we will create O for the second O, and then we will create another node for L, correct? So this is how the cool word will be mapped into the try, right? So that's what we are doing here into this insert method, correct? So we will always check if the node is not already there, means null, then we have to create a new node, right? If it's already there, we will just use that node. So that's what we are doing. And at the end, after this for loop is done, for loop we are going through each character of the word, right? So after that one is done, we will just mark is word is equal to true, correct? For example, here for the L we will mark is word is equal to true, like dollar, for example. For this T, CAT, this is the end of the word, right? So we will mark end of the word here basically, correct? So that's what we are doing in the insert method. After that we have a search method. So why we are doing it? Because our solution is based on try data structure, right? So we will need insert method and we will need a search method also, right? So search method, we will start searching for a word from root, right? So we have to make sure that that node is already present. For example, if we are, let's say, let me just change the color quickly. So for example, if we are searching for cool, right? So we will first check if C is there. Yes, C is there. Then we will check O. O is also there. Yes. Then again we will search for this O. O is also there in the try, right? As its child, right? And O's child L. L is also there as a child, and it is also end of the word, right? So we will just return true. So this is the search in the try, right? So this is what we are doing here. So we'll go through each and every character and make sure that the node exists there. At the end, once we have seen all the characters in the word, we will just check the last node, right? If the last node is end of the word, then it means that the word is present in the try, correct? So this is the try data structure. Basically we have seen insert and search method. Now we will actually go to our original method, find all concatenated words in a dictionary. Words string array is given to us. So first we will just create a try here and we insert all the words in the try, right? So as I shown you here, this is how the try will look like, right? After insertion, this is the try basically, correct? So that's what we will do. After that, we will just create one new array list here, because that is what we wanted to return at the end here, correct? That is what we want to return as our answer. And we will go through each of these words that are given to us, correct? and we have just one recursive method called as util implemented. We'll just pass try, we will pass the current word, and we will pass a flag as a false, right? I told you the flag basically, right? Cut word if possible, right? Cut word possible. Why we need that flag? Because we want to understand that, for example, if we are looking for word cat, right? Cat, so cat word is there into the try, but that doesn't mean that it's a concatenated word, right? Because it is only single word. We want more than one word to be present in the try, right? For example, dog, cats, cats, right? Cats, dog, cats. More than one word is present, right? Cats is present, dog is present, cats is present. Then only we can say that it's a concatenated word, right? So to understand that, we need a flag, right? So flag tells us that we are finding more than one word basically, right? So cut word possible is the flag. So let's just go through this util method now quickly. So what util method is doing is, first we will check, we will get the string that we are currently working on, right? Currently working in the sense is the prefix string, right? So first C, then A, then T, right? We are basically, for example, let me just remove this color so I can again use this space and show you that. So for example, first we will go like with C, right? We will check in try, then we will go with CA, again we will check with the try, then we will go to CAT, we will check with try, right? If that word is present, right? So that's what we are doing. So that prefix string is this S, correct? And if let's say we are end of the, like if we S becomes empty basically, right? And if the cut word is possible, then it means true, correct? Because it is the case where we have found all the words which are present in try. So let's just let's first go through this for loop, then you will understand. So first we are starting with 0 and we are going to s dot length I plus plus, right? So we are calculating the prefix, right? So as I shown you here, we are calculating the prefix. First C, then CA, then CAT, right? And after we calculate the prefix, we are going to check if the prefix length, right? The s dot length, this string dot length is the complete word basically, right? I is equal to s dot length and cut not possible, then we will return false. Otherwise we will just go through, we will search for that prefix in try, right? And we will recursively, if the word present in the try, then we will recursively call our util method with the remaining of the word, right? This s dot substring I plus 1 will call that with the remaining of the word, right? And here this is a very important thing, that we already found one word which is already in the try. Now we will change our flag to true, right? In the beginning the flag we are passing is false, right? As you can see here, the flag is false, which means that we have not found one word yet. And when we found the first word, we will change that flag to true, which means that now we are finding the second word, right? So this is how we understand that we have a concatenated word, right? So for example here, CAT, so let's just say CAT. So CAT we found, but now when we are searching for this other remaining word, S is not word basically, S is not there, right? So we'll just return false, so it's not possible. Now what we will do is we will go with, we will keep processing with our prefix. So now our prefix will expand to CATS, correct? Because it's a recursive function, right? So CATS will be our prefix, and we found that CATS word here in the try. CATS is there, correct, in the try. So we will now change our flag to true, right? Our flag will be true basically, means that we already found one word. Now we are trying to find the remaining words. So now again we will keep going like D, then DO, then DOG. Once we go DOG, we will again find DOG here into our try, which is a word, right? Then again we will cut it basically, right? We will cut it like this basically, right? So this dog is again there, the again our flag will be true only basically, correct? Flag will be true, which means that we already found now uh, more than one word basically, right? So we are just passing the flag as true. Now we will again keep checking with this cats, right? Cats is there into the try. So totally once we reach here, then we already have a flag true, and we already found all these words into the try, correct? Then we will return true basically, right? So that is what we are doing here. So as you can see, the s we are doing is we are cutting the string basically, right? S we are doing is we are cutting the string, correct? First, as you can see, once we find cats, we cut the string. Now the string becomes dog and cats, right? Dog, cats. So once we find cats, then our next string that we will be passing to our util function is dog cats, correct? Dog, cats. That's what we will pass. Now once we find dog, then the next string we are passing to our function will be cats, correct? Because that is the only remaining string now. And once we find the string cats, our prefix will be just an empty string at this time, correct? Because we already found cats, so now we will just pass empty string, correct? So as you can see here, we will keep always checking if s is empty and cut word is possible. Means if it is true, then it means that we found a word that can be concatenated, right, with couple of words, because our cut word possible flag will be true. So we will return true here, right? Otherwise we will just return false, right? That it's not possible basically, right? If it is possible, like to cut the word, and if our function is returning true, we'll just add it into our result list, right? It's a list of strings that we are going to return, correct? So I think I explained this with very detail. You know, if we reach here, we'll just return false, correct? Means we have taken a look in all the uh, characters of the words, but we did not find it, so we'll just return false here. So this code has all the comments also, right? So first we are inserting into the try, then we are actually will check with all the prefixes, correct? We will call with each word and we'll check if that word is can be a concatenated word, right? And in the util, we will always keep breaking the string basically, correct? Using the prefix. As you can see here, we are doing the prefix, right? S dot substring from 0 to I minus 1, correct? So I will keep incrementing. So as you can see, first C, then CA, then CAT, then CATS, like this, right? The prefix. And we will search that prefix into the try here. If the prefix is found in the try, then we will update our flag to true, and we will keep checking with the remaining string. This is the remaining string, right? S dot substring I plus 1. It means that we are passing the remaining string, correct? For example, in this case, once we find cats, then we will use cats, correct? So this is how our solution works, right? So let's just make sure that our we will just use our solution here, right? So this problem is Leetcode. So I just lost that window, I think. Let me just get that problem quickly. So this is a 472 problem, right? Leetcode 472. So this is our problem, right? So let's just submit our code and make sure it works. So I'm going to submit the code now, right? So our code is working. As you can see, it is accepted. I'll go ahead and I'll submit our solution now. So our solution got accepted by Leetcode. It is 76% faster on performance and 40% faster on memory side, which is pretty good. So our solution got accepted, that uses the try data structure and uses the logic that I explained you in this whiteboarding session. So so let me just bring back this window here quickly, right? So if you are new to my channel, then there is a dedicated playlist on my channel called as Leetcode and Leetcode Solutions. It has over 200 different varieties of problems solved and explained with whiteboarding session examples and Java code. So if you are preparing for any Java J2 interviews or coding interviews, that playlist can definitely help you. If you want to practice for more coding interview questions, there are 3 other playlists you may want to consider on my channel. The names are Code Forces, Code Chef, and AdCoder. All in all, you will have more than 400 different varieties of problems explained with whiteboarding sessions, examples, and Java code, as we just did in this case, right? And all the codes are also available on my GitHub account. I'll also put this code on my GitHub account. You can check it out from there and play with the code with different examples for your better understanding. Uh, if you like this video, if you find this video helpful, if you like it the way the video has been created with whiteboarding session, examples, and Java code, then please give it a thumbs up or give it a like to my video. That will be really helpful. Also subscribe to my channel. Your subscription to the channel is really important because that is the way the videos can reach to more people who need help in solving coding problems. The main goal of the channel is to help people in their coding problems and their Java J2 interviews, so they can watch these videos and understand how to approach different coding problems and how to use different data structures to solve different varieties of problems. So if you like this video, please give it a like. Also, if you can put into the comments how you found this video helpful and how you understood the problem easily with this video, so that I will get the feedback from the comments. So please put into the comments. If you have any friends or colleagues who are preparing for Java J2 interviews, then please share these videos with them. They can also look into these videos and get benefited by watching these videos in their interview preparation. Also check out the code from GitHub. If you like my Java solutions on GitHub project, then please consider giving it a star to my GitHub project. That will be helpful. If you have any questions related to this video, then please put your questions below the description section so that I can answer your questions. So let's just go ahead and we already submitted our solution, but let's just make sure. So our solution got accepted by Leetcode, right? Uh, keep coding and keep learning. And also, one other thing I wanted to mention is that this problem also can be solved with the help of DFS also, right? But in this video, we are just using try to solve the problem. You can also try solving this problem with DFS. Okay. Thanks for watching this video.